Again to my channel. Today we'll be looking at direct and inverse variation. Topic variation. Variation can be we have direct variation, we have inverse variation, we have a joint variation, and we have partial variation. But for this my part 1 class, we'll be looking at the first two variation, which is the direct and the inverse variation. So I'll be taking a few examples today. I will explain everything I know you need to get this topic very, very well. But don't forget, I will not waste your time. I will just go straight, hit the nail on the head for you, and give you what you want in a jiffy. So all you just need to do is to take your pen, jot and write, and understand. So if there's any question, you can always ask me under the comment section. Let me start. So let me start today in let me digress small. On physics, whenever you hear that something is varying directly, there must be a constant K. It's normal, there must be a constant K. In Charles' law, Boyle's law, if a gas, the volume is varying directly or inversely, K must be introduced. Hooke's law of physics also, K must be introduced. Now, back to my problem now on variation, mathematics. The first thing you will do is this. Note from the question, what is varying? Is it varying direct or is it varying directly? So number 1 is varying directly, number 1. Number 2 is varying inversely, number 2. And number 3 is varying what? Inversely, number 3. Is varying directly, number 1. Is varying inversely, number 2. And is varying inversely, number 3. Now what will I do and how will I start this work? First of all, what is varying to what? A is directly proportional to what B. How will I solve this number 1? A to what? To B. It's directly to B. If I now introduce my constants, it will now be A equal to KB. Why do I have KB? I have KB because it is what? Direct. Not K over B. Whenever you now have direct variation, the answer that you have will be what? Your equation will be straight in a linear pattern, no longer in a what? In a fraction pattern. Because of what? It is varying directly. Now look at my question very, very well. Do I have other ingredients or other elements in my question? Let us go back to my work now. If A is directly proportional to B and A is equal to 36, they did not mention square roots, they did not mention square. Remember, square and square root are two different things. Square root, you look at square root, square, look at square. They are two different things. Is it square root? Is it cube root? Is it fourth root? You should know from the question. But this number 1 is very simple, it's very plain and straightforward. Now, there's no need of hitting and solving heavy questions why you don't understand the smaller ones. Why building house, you start for the foundation, after which you now climb and go up. So if I give you fourth root now, fifth root now, without you understanding the basic now, it might give you issue. So what am I even saying? Look at my first work. No square root, no cube root, nothing at all. They only said if A is directly proportional to what to B, and A is what this, and when B is 9, so find this one first of all. Now, whatever you will do, both direct, both inverse, both joint and partial, you must find your constant. To find my constant, they have given me a condition that A is 36. I remove A and I put what? 36 equal to K, I don't know, times. Whenever you now see two letters together, they have times making them. My B here is what? My B here is 9. For every normal student, to now find K, I divide it by what? 9, divided by what? 9. Now look at this. At this point, 9 will cancel 9. Therefore, my K will now be equal to, let us go. 9 will go here 1 time, 9 will go here 4 times. So now, 4 times. So my K is equal to my what? To 4. My K from my question is equal to my 4. Now, I want to wipe my topic. Remember, my topic is direct and what? Inverse variation. I'll be solving the two of them at the same time. I will spot and tell you their difference in this my part 1 lecture. In my part 2 lecture, I will then go to partial and joint variation and tackle and treat them at the same time so that you understand. Remember what I said before? When it's direct, it will go straight. And look for other ingredients or elements in the question. For what I have here, it is direct and straightforward. No square root, no cube root, and nothing like that. Now, I want to continue this number 1. They said I should find the what? Relationship between A and B. Now my A answer now is now equal to, look at what I will do. My A is equal to, what's my K? My K is now 4. 4B. Look at my equation. Look at the equation linking A and B. If this thing is wrong, it means that whatever I will solve further must be wrong. But if here is correct, whatever I will solve further must be what? Must be correct. But for my work here, my A is equal to 4B. This is my what? My relationship. The second one says that I should find A when B is equal to 3. I will bring down my equation. Since A is equal to 4B and I'm asked to look for A 4 times what is B? 3. Therefore A is equal to what? 12. A is equal to what? 12. 4 times 3 is what? 12. That is my B answer. Then my C answer is now equal to what? I should find what? B when A is 32. Look at my equation. A is equal to 4B. I'm looking for B when A is what? 32. Equal to 4B. What will I do? Divided by 4. Divided by what? 4. 4 cancel 4. Therefore, 4 cancel 4. Therefore, only B is now equal to 8. My B is equal to 8. I'm done with number 1 question, which is direct variation. It's a direct variation. And I'm done with the first one. Now let me rush and look at the second one. Look at the second one. It's not inverse. As I've spotted, I've told you before that since it is now inverse variation, look at what we will do. What is varying and what is varying to what? P is varying inversely as the square of Q. Solution to number 2, they say P is varying what? Inversely as what? As the square of Q. As the square of what? This is the square of Q. If they had said square root of Q, I'll be writing this square root of Q. But they have said square. Look at what they say, square of Q. So I will then put that Q, P is varying inversely as what? Square. And if I go before, I will then get what? That P is equal to K over Q square. Look at what it means. Why will this K come on top as a fraction form? Because of its what? Inverse. If it's direct, I will have P equal to KQ square. It is direct. But now it's inverse. It will now go like this. If I solve this further, they said when P is 3, I remove P and I put what? 3 equal to K I don't know all over. What's my Q? My Q is what? 2. 2 is power what? 2. If I solve this further, what will I get? K will come down and we cross multiply. Cross what? Multiply this. To find my K is equal to 3 times 4. I express 4 of 2 is 4. 3 times K is equal to what? Therefore, K is equal to 12. K is equal to 12. This is my final answer. My K is 12. Then, even without they telling me to find the equation, before I will solve, I need to find the equation. And how will I now find the equation? I have to find the equation. How will I find the equation now? I will come back to what I wrote before. My equation of number 2, the equation is P is equal to 4 over Q squared. P is equal to my K. I remove my K and I put what my K stands for over what? Q squared. So that now, my first question is I should find what? Q when P is equal to 3. I should find what? I should find Q when P is 3. What will I do? I remove my P and I put 3 equal to 4 over Q squared. I remove my P and I put what they give me as condition here. P, I remove my P, I put 3 equal to 4 over Q squared. Therefore, if I multiply, I now have 3Q squared is equal to 4. Divide here by 3, divide here by 3. 3 cancel 3. Therefore, Q squared is equal to. We went on. Okay, from what we saw before, what was our K? What was our K? When we saw before, our K was what? Okay, sorry for this. Let me just. From this their question now, we are being told that if P is equal to, the P here is sorry please. The P here is equal to 3, equal to K I don't know. What's my Q? 2 squared. 2 squared. Therefore, my K is equal to 3 times 4 is equal to 12. My K is 12. So therefore, my equation will not be, thank you so much for that correction, will not be P equal to 12 over Q squared. This is my equation. Thank you so much. This is my equation. I'm supposed to put 12 and not 4. So if I have to solve this now, they say for the second one, the first problem, I should find Q. Q, when P is equal to 3. Q, when P is 3. I will come back to my question. I remove P, I put 3 equal to my 12 will come down all over my Q square. So here 3 times Q square, I have 3Q square equal to 12. I have 3Q square equal to 12. From here, I have 3Q square equal to 12. So from here, I divided by 3 divided by 3. 3 cancel 3. Therefore, Q square is equal to 4. Therefore, only Q is now equal to the square root of 4. Q is equal to what? 2. From my formula, I have that P is equal to 12 over Q squared. So I did this times this. P, I removed P and I put 3 here. Look at the 3 equal to 12 over Q squared. 3 times Q squared gave me 3Q squared equal to this 12. So I divided by this 3 and by this 3. 3 cancel 3. Only Q squared is equal to 12 over 3, which is equal to 4. They say find Q, they don't say find Q squared. Therefore, to find only Q is not equal to the what? Square root of what? 4. But if here was square root, they say find Q. I will not take the power of 2, the square of 4. But here I have the Q square. To now find ordinary Q is not the square root of 4, which is equal to 2. This is my number 2 answer. Then for number 3, I'm being asked to find P. Look at my equation. P is equal to 12 over Q squared. I'm asked to find P when Q is 3, right? So here I will now put 12 over 3 squared is equal to 12 over 9. It is equal to 3 here is 4, 3 here is 3 here is 4, 3 here is 3. Answer is 4 over 3. This is all for number 2. Then let me go down to number 3 and then wrap it up at that point. Wrap it up at that point. Let me go to number 3 and wrap it up at that point. Number 3 and wrap it up at that point. Then P is inversely proportional to the square of Q. P is I'm going straight to the what? To the square of Q. When P is 2, I remove P, I put 2 equal to K, I don't know, all over. What is my Q? My Q is 2. If I solve a work like this, 2 square. Therefore, my K is equal to 2 times 4 equal to, my K is equal to 8. Let me recap. Let me go back again to what I said earlier. That my P, I remove my P and I put 2 equal to my K I don't know, and my Q is 2. This Q is 2 square. 2 is now 2 from here. K is equal to 2 times 2 square is 4. 2 times 4 is equal to 8. Then we are now asked to find I, the first problem. We should find Q when P is 4. So from here then, look at my equation. The equation is P is equal to 8 over Q squared. I will not solve all, I will stop somewhere. When my P is 4, I remove P, I put 4 equal to 8 over what? Q squared. 4 times Q is 4Q squared equal to 8. Divided by 4, divided by 4. This 4 will cancel 4. Only Q squared is now equal to 8 over 4 is 2. 8 over 4 is 2. 8 over 4 is 2. Therefore now, what will happen here is this. From here, what I will get here is that I will then get ordinary Q is equal to the square root of what? 2. Let me confirm square root of 2 is equal to what, please? Therefore, square root of 2 is equal to 1.41. 1.41. This is my answer. Then, if I continue this, the last part, which I know I will not solve all, I will stop somewhere. We are asked to find P. P, I don't know, equal to 8 over, this Q is now 1 over 2 raised to the power of 2. That's what I have. Look at my Q. My Q is not 1 over 2. Remember, for the formula, we have 2. We have 2 on top. So it's now 8 over 1 square is 1, 2 square is 4. So if I solve this, I will then have 8 divided by 1 over 4. 8 divided by 1 over 4. So from here, 8 divided by 1 over 4. Here, 8. I change it to times, therefore I will then convert it 4 over 1. Therefore, 8 times 4 is equal to what? 32. Final answer. Thank you so much. We have come to the end of today's class. Once again, I am Brain Booster, and I will meet you in my in the part two lecture of direct and inverse dilation. Thank you so much.